Hello, everyone. Thank you for joining us today at the HSE University's online Master of Data Science degree programs industry webinar. And today, our speaker is Artem Filatov, and we will cover interesting sphere and field like in computer vision. So before we start, I'd like to specify and mention several organizational moments that the recording of this webinar will be available in a few days, and we will send information via email, and also you can find the link on our website, of the program's website. If you have any questions during the presentation, you can type them in the Q&A feature. So there is a chat box and also Q&A. Please ask your questions in Q&A because it will be easier for us to track all your questions. After the presentation, we will have the special part like a session for Q&A, and we can cover all your questions. So, okay, Artem, we can start.
Thank you. Hello, my name is Artem, and let me introduce myself. I'm working in the Yandex self-driving group, where I'm working on the self-driving vehicles. And in precise, I am doing computer vision there. So my job is to guarantee that our self-driving car understands the world around and can see everything around. Okay, yeah, let's start. And I will tell you about computer vision, about my thoughts on this field. And let's start with a simple question, which is very popular actually on such type of lectures. And the question is, which of these people are real? And it's was a really weird questions just about a few years ago. But now we actually can't give clear and confident answers. And actually, both of them are generated by the neural network. So these two people have never existed in the world. And it's pretty crazy because only in 2014, we didn't even dreamed about such results because on the left, you can see the results from 2014. And it looked very real in 2014, and we thought that it's a stunning result. But it occurred that stunning results are yet to come. And this work, the work that presented these images is the work by the NVIDIA group, and they published their results in 2018. Let's see another examples of modern computer vision, which are changing our everyday life. So you know that there are a lot of, for example, Instagram filters and so on that are using artificial intelligence technologies to generate a new experience in the applications when you can use your phone to do a very interesting things. And this is one of them. We can generate a new environment for the picture, new weather, new day of the time, sun, fog, and so on. Augmented reality and virtual reality also delivered a lot of stunning results in the past few years, and now just with our phones we can place new objects in the world around us and interact with them. So the medical revolution, where computer vision is used to analyze such photos of our brain to help to find some diseases and so on, which is also very helpful for the whole world. And it's great that that we have such technologies. And sorry, okay. And here you can see um, the road where object detection algorithms are capable of detecting different objects on the scene, and such technologies gives us an opportunity to build a completely self-driving car to make our lives also better. So as you can see, we are actually in a quite interesting place and in history, and the field, the computer vision field, delivered a lot of cool and great results in just a few like couple of years. About last, all the results that I presented was impossible about 10 years ago, and we even didn't think about that. So how did we achieve this? How we came to this point? How it is even possible? Let's take a brief introduction to the history of computer vision and look what personalities and what events changed the way we are living now. In 1989, Jan LeCun presented a simple algorithm for recognizing zip codes on the letters with a small first neural network. So how does it work? How did it work? He his idea was very like natural, but he was the first to come up with it. In computer vision, in like classical computer vision, we have an operation of convolution. Convolution is just a simple function that you can apply to different elements of your image, to different patches, and analyze this small patch of your image independently. And usually these filters people created by themselves. So they just started to think which filter I need. So trying to invent some parameters of this filter and to solve some problem. For example, to detect the boundaries on your image. And there exists a simple filter that was invented by just man that is capable to detect the boundaries on the image. But Jan LeCun said that, okay, maybe we don't need to invent these filters. Let algorithm decide which filter he needs. And this is how a small neural network was invented with convolution, learnable convolution operations, where neural network decides itself what filters and what parameters it needs. Okay, and he solved this task with confidence, like it worked great. But then there was a great gap, actually 20-year gap in development. So it was an interesting result, but people didn't understand how to apply this algorithm to their task. The programming of like it was difficult just to write code. Yeah, of neural network. people didn't understand how to train them, how to scale it, and so on. So in 2010, the ImageNet was published. What is it? ImageNet is dataset with 1 million pictures. It is small pictures, and the goal was to detect, to understand the class of the object that is presented on the picture. And it was a very very difficult, of course, to collect such a data set in 2010. It was actually collected by the students, if I remember correctly. And some professors in the computer vision field just didn't understand why we need this, how it can help us. And but the organizers of this project were confident that it's what we need. We need just large data set to start push our field further. And it actually, they were right, because after this data set was published, the deep learning revolution started. And so people, researchers started to apply neural networks to this task. It's called a classification task, and started to push field. Yeah, and they achieved a very great results. So this was one of the events, like one of these very important moments in the computer vision, which changed computer vision completely. After ImageNet was presented to the public, the deep learning revolution started, and people started to apply neural networks to solve this classification problem. And they were struggling in the beginning because here you can see actually the timeline here is from right to left. Yeah, and in the beginning, in 2010, the error rate was relatively high. So we the algorithms made mistakes on 28% of the images, which is a very high error rate. And then researchers started to increase the number of the layers in their neural network. They actually started to increase the number of parameters in neural network. And so the interesting thing started to happen. The larger, the bigger the network, the deeper the network, the better results were achieved. And in that time, researchers understand that all we need actually is to make a really deep neural networks, and they will be able to solve a lot of different tasks. It was only partially true, so it not a silver bullet to our problems, but it is a very important thing that now we have no doubt about. So we need deep neural networks to solve complicated problems. Okay, but all this very impossible without special computer units called GPU, graphical processor unit, um, which helped a lot in this revolution. So graphical processor units were found really useful in the deep learning because graphical GPUs can simultaneously perform thousands of small, simple tasks. And so the speed of training neural networks and inference was restricted by the number of parallel units that we can simultaneously use. So what did I want to say? I want to say that, yeah, actually this graph is correlated with the development of graphical processor units. And when our technologies, computing technologies, delivered a new unit, a new like model of this GPU, in that time, researchers were able to start push the limits of deep learning and create deeper networks. And why it's so important to simultaneously perform small, simple tasks? It's simple because actually neural networks is just a bunch of matrix multiplications and another simple mathematical operations. And matrix multiplication is a well parallelized task, and we can divide this task of matrix multiplication into small pieces and compute the results in parallel. This is why GPUs are so important. And actually GPUs still, the development of GPUs, the development of like a new GPU architectures is still a very important part of field development. So we still have this like, yeah, you can see here that over the last decade, the computational power of GPUs rises exponentially, and it's great because with bigger computational power, we can train and create larger models. There exists a Moore's law in computer science, which states that every like couple of years, the computational power of CPU is rising by some factor. And actually it states that computational power of CPUs rises exponentially. And it was true until 2010. And in 2010, this rise was stopped, unfortunately. But GPU came to the world, and just in GPU, we can now see the second Moore's law, where GPU's processing power is rising, which is great. Because maybe you heard that now there exist models, neural networks, with billions of parameters. And of course, it were impossible about a few years ago without important breakthroughs in GPU development. And oh, sorry. And another important thing that I want to mention about deep learning and um, why we achieved a lot of results in such a short period of time. It's also because of frameworks. There exist really simple and convenient libraries uh, that every programmer, even non-professional, can use and create their own simple neural network, train their models, and finally solve uh, their tasks. This is what we all want to do, solve our tasks. And yeah, and these frameworks, for example, TensorFlow or PyTorch, um, they helped a lot. They simplified the development and research a lot, and it also helped a lot in this revolution. So, what do we have now? What do we have now? A lot of applications. I mentioned few of them in the beginning, like Instagram, medicine, self-driving cars, a lot of. The huge amount of data was collected and continue being collected. And now, like in every industry, mm, in every team, there exists a simple solution to a lot of difficult problems. And usually the solution is the following. You need to collect a data set and then program a simple neural network, train it, and your task will be solved with some error rate, which can be not perfect, but it's better than zero. Okay, and yeah, but we still have a lot of challenges, and these challenges are really difficult, and we don't know how to solve them completely, and we don't know if it's even solvable. So if we can do this. One of these challenges is the 2D to 3D correspondence. What is it about? So the problem is the following. We want to understand the 3D world by the photo. People can do it very, very good. So we have two eyes, just like two cameras. And with these two eyes, we can understand the shapes, we can understand the distance, and a lot of other things. And we don't have any troubles interacting with the 3D world. But machines have troubles, unfortunately. And it's really difficult to understand a 3D world by 2D images. There exists some even ambiguity, which states that there are some cases where we cannot say anything about the 3D world by 2D image. But in general, we can, and we want to solve this general case. But there were some great results in past few years, and let's look at them. This is one of the results called Nerve in the Wild, and this paper suggests the algorithm that can generate reconstruct a 3D scene by the few images. And this is the results. By a few dozen of images, we can reconstruct a 3D scene, understand the depths, understand the shapes, and we can generate novel views um, from the unseen camera positions. So like if you want to move camera and take a photo from another angle, you can do it without actually doing it. You don't need to move the camera. You can ask this algorithm to generate a novel view for you. And you also can see that we can change the environment. And yeah, it works really well. It was a very important result in the field, which um, delivered like a new hope that this task is actually solvable, and we will be able to do it in a few years. Okay. This is another example of depth estimation. The paper called Consistent Video Depth Estimation, and it describes the algorithm which is able to to understand the depth in the scene. And the brighter the color here, the closer the object to us. And neural network is able to understand the distance only by video, which is great. And on the right, you were able to see the example of how we can use it. So for example, we can generate some video effects in 3D and yeah, deliver a new experience for people. Okay, let's move. Another interesting problem, which is actually also very difficult, is called one-shot learning. Again, I have analogy with people. So for example, when you learn a new concept, you need just one example of this concept to learn it, right? I can show you a new animal, and I will name this animal for you, and you will able to recognize this animal in any environment, in any conditions. Maybe I will show you the male animal, but you will be able to recognize the female animal and even understand that this is another um, gender. And yes, okay. So for people, this is a very simple problem. We have like memory, right, to do it. But for the computers, it's very difficult because all we do. So the mainstream in the deep learning is to collect more data and create a deeper neural networks. And deep neural networks requires a lot of data to train it. And they are not satisfied with one example. If you show a neural network one example, then this neural network will be able only to recognize this one example and not another one. So it's not generalizing well. Yes, and so yeah, it's like not mainstream, and this is why it's very difficult. So how it can be learned? What ways to solve this problem? So you can imagine like something like semantic map, where similar objects are positioned close to each other, and unsimilar objects are far away from each other. And having such manifold, semantic manifold, you can put new examples, new concepts on this manifold. And when you can see something in the wild, in the new environment, you can just look at this manifold, look at the closest neighbors of your concept, and understand what it is. It's one of the ways, and it is there exist some works that try to exploit this idea, but we still have a lot of things to do. And one-shot learning is actually have a strong connection with another problem of concept understanding, because machines, they do not operate in terms of concepts. They operate in terms of like separate pixels or separate characters in the text, but not in terms of concepts. And this is why it's very difficult to demonstrate a new concept and suggest a neural network to remember it. And solving a concept learning, understanding how we can put this knowledge into the neural network can also push the area even further. Okay. Another example of challenges that we have is AR and VR, augmented reality and virtual reality. I demonstrated some example for you in the beginning, but it's not enough, of course. It's all fun and games that you can have a police car on your table, but this is not the reason why we want to solve the augmented reality and virtual reality. The main reason is that we want to have telepresence experience. We want to communicate people from all over the world, and we want to communicate in an authentic way. So we want to see the person in 3D. We want to interact with them. Maybe we have a common project, and we in virtual reality we can communicate with some virtual objects and create then like solve some engineering task. I don't know, just or play games with each other. And unfortunately, we are far away from this point. A lot of laboratories are working on that. For example, Facebook has Facebook Reality Labs. This is a branch of Facebook which concentrates only on the task of augmented and virtual reality. Oculus and a lot of another companies that want to be first in this race. And here you can see the result of the Samsung AI Research Center, which is located in the Moscow, and this is the result of their paper, where they generated neural avatars for the virtual reality telepresence experience just by special cameras that you can see on the left. Okay, so now problems that seemed impossible about 2 years ago are now solved, and this is great. And this gives us a hope that problems which we are thinking are impossible now will be solved in 20 years. So I demonstrate you some challenges that area is actively working on. And yeah, let's hope that these challenges will be solved soon, and solving them can also change our lives very rapidly in a better way. And probably you heard about natural language processing. This is a field of deep learning which concentrates on the understanding of the texts and generating texts and translation and so on. So working with languages and texts. And natural language processing and computer vision are two branches of this deep learning revolution. And unfortunately, currently they both use neural networks, of course, but they use quite different approaches for their problems. They use, like, if you want, different neural networks with different structure to solve their problems. And natural language processing currently are delivering even more stunning results than computer vision. For example, GPT-3 model that OpenAI published in 2020, and this model can generate text, news, I don't know, even code from just scratch on request. And sometimes this text or code is indistinguishable from people. So you can tell that this text was written by the machine, and this is very great. And this results in natural language processing are giving us hope that one day we will be able to merge these branches, that actually we will use same methodological approaches, and all the achievements that were completed in natural language processing or computer vision, that we will be able to share these achievements and to merge these two branches with one approach. So this is all. Thank you. Now you can ask me some questions, and I will be glad to answer them. Do you use standard libraries like OpenCV, for instance? Yes, sometimes I use OpenCV. So OpenCV, for you who don't know, is a very popular library with classical computer vision algorithms. Under classical computer vision, I understand the computer vision that was invented before deep learning era. And yeah, it's useful sometimes. Work with images, like apply some transformations, do a lot of other things. OpenCV can help a lot, yeah, working with images. it's just such a big library with a lot of different like functions and utilities that it's just very convenient to use. Dear Mr. Filatov, a question regarding one-shot learning for ML algorithms. How different would be the task of generalizing concepts, generating hypotheses, building on experiments? Thank you. So, generalized concepts and generating hypotheses. I think I don't quite understand the question actually. If you could specify it, it would be great. So if under generating hypothesis, you understand, for example, I have a pedestrian on the street and I need to guess where it goes now. If this pedestrian is going to cross the road or not. And now there exists some works where neural networks can generate the hypothesis about the future state of our world, of where this car goes or where this pedestrian goes. And but generalizing concepts is like, I would say this is a part of every neural network algorithm. It's what we're trying to achieve. With millions of examples, we try to say neural network, just look, there exists a very different environments, very different conditions, but this is cat. Forget about the other things, forget about the carpet or the floor and the window. It's not relevant. Just learn the concept of cat. And this is what we're trying to do in actually every deep learning problem. Yeah. Okay. Given many psychological researchers points to very close relation between perception and actions. For example, we don't perceive objects as abstractions. We perceive them as objects to act upon, almost at a biological level. Are there any researches in this area, especially given recent achievements in automated robots and machines? So currently, these two branches, perception and like interaction with the world, are separated. So the perception is about computer vision, and interacting with the world is about reinforcement learning field, which also has very stunning results from OpenAI company and from another companies. But unfortunately now, yeah, it's separated. In reinforcement learning, we treat the world around us already as a set of actors, of some objects that are going to act. And in computer vision, we don't. We just don't understand now how to close this gap, how to create algorithms that can from image understand the objects and then like understand their actions. Unfortunately, this is an open problem. How do you see a future of a deep learning and computer vision in general from mathematical point of view? It seems that so much researchers and engineers are in deep learning now. They already applied plenty of neural networks for a very high range of tasks. I'm not sure that they will continue to play with different black box architectures for the next 10 years. What do you think? It's an interesting question. So what trends I can see? Maybe we will be able to better understand neural networks. It would be very good because now we are like physicists in 19th century. We are just conducting experiments. We achieve something. We see, oh, electricity. Wow, I'm going to use it. Why it works? I don't know. Maybe one day I will know, but now it works, and let's go to use it. Yeah, maybe in the coming years, we will see some theoretical results regarding the deep learning and our understanding of the neural networks from theoretical perspective. It would be very great because now like good researchers and good engineers are actually those that have a good intuition, like maybe it should work. I don't know, but in the past, my experience tells me that yeah, maybe it should work. So it's not like strict science with proofs and all this stuff. Not good, not bad, but it is what it is. And yeah, this is one thing. Do we continue? Will researchers continue to play with different black box architectures for the next 10 years? So now the point of interest is shifting towards very large models, which that can like understand the world, if you want. So the large natural language processing models is one example. In computer vision, we just try to solve these tasks. I don't know what we are going to do after this task are solved, or for example, if we solve perception in self-driving cars, and we will be able to see to understand this world like without any uncertainty. Probably it's not possible. And what all these people gonna do? So in the industry, there are a lot of tasks to solve, and I'm sure there are a lot of yet to come. And in industry, I think we will have a very like long. We will have a very long story here. What will be the point of interest in research? I don't know. Everything can change very fast. I hope there was a lot of words. I hope that I answered your question. I worked in the time series forecasting heavily since the last few years, and now want to venture into computer vision and NLP. What would be the best path resources that I can follow to learn the same? So what will be the best resources? If you are like feeling good yourself in machine learning, in basics, like you know boosting algorithms, you know logistic regression, you know what is binary cross entropy, and so on, then you're in a good shape, and all you need now is to transfer this knowledge into a new field. You can do it with books. I can't tell you the exact books on computer vision and NLP now, but there are not plenty of them, and I'm sure that even in computer vision there exists one really popular book that you can learn, or there exist some online courses, for example, on Coursera on computer vision, and NLP. I think Coursera is a good way to learn something new. I followed this path myself. I learned a lot of new things on Coursera and another online learning platforms. So yes, I would read books, watch courses, and then I would try to create, to make a project in computer vision, for example. You can find some interesting tasks on Kaggle, or come up with your own ideas and try to learn it. And then after you will get a general understanding, it's very important to start read papers. So in computer vision and natural language processing, papers are relatively simple. And if you want to understand this field better, if you want to be a good researcher, good engineer, you need to read papers. There exists some popular conferences that you can just look through and find the papers of your interest and read them. These conferences are ICCV and CVPR. It is in computer vision. In natural language processing, I unfortunately don't know about the top tier conferences. But there exist NIPS, neural lips, and ICLR and ICML, where top papers are published. And with these conferences, you will be able always be on the top of the research. You will be able to be in touch with the industry and area. How do you train the neural network for cars without pilot? Do you use some kind of simulation in order to train the network, if this is not NDA? So we don't have, actually the problem of self-driving is separated, is decomposed into different problems. Most simple one, for example, the problem of perception, where we need to understand the world around us with computer vision. The problem of prediction, where we need to predict the future states of the world. The problem of motion planning, when we need to plan our trajectory, and so on. So it's just very cool idea to have one neural network that can do self-driving. Unfortunately, it doesn't work. And all the top companies in the industry are separating this complicated problem into more simple ones and apply. Sometimes they apply neural networks into this in these sub problems, and sometimes they decided not to do it. What technology skills do you use as a computer vision engineer? Can you please tell us about task problems you've been working on recently? With great pleasure. Yes, so what technology skills? So in this type of questions, I always tell you that you need to be a good programmer. I think it's very important. Even if you're a researcher, if you're an analyst, whatever, you need to be a good programmer. It will. So the good programming skills won't restrict you in the things that you want to solve. So, for example, you can come up with a brilliant idea, but you think, oh, it's too difficult to write that code. Probably I shouldn't do it. So programming shouldn't be the problem for you. And of course, you need to have a great intuition. You need to understand the field. You need to read papers. So in the industry, it's so we have a solution, right? So some neural network, but this solution isn't perfect. It delivers us some errors. And now the goal of the researcher is to sit and think, okay, I can see these errors. What these errors tells me about the algorithm, why my algorithm is doing these errors. And with all your knowledge, with all your intuition, with all your understanding, you should guess and you should generate a hypothesis, probably a few of them. And after that, you're going to check this hypothesis. And luckily, some of them will be true, and you will make your neural network better. You will solve, you will close some problem inside the neural network, and so on. So, like high level, it's look like this. And recently, I'm working on sensor fusion algorithms. It is algorithms, detectors that aggregate information from camera and LiDAR and radar and a lot of different sensors. And the problem is that these sensors provide very different data. And so the intuition is that they should like help each other, right? Is a complementary, this is a complementary data. It should help. But on practice and in literature, it's very difficult to achieve something with this new level of data, new, sorry, not level, but new sources of data. And so, yeah, it's my, and I'm trying now, and I have some great results. Unfortunately, I cannot share with you. And I'm trying, yeah, to create the algorithms which perform this sensor fusion with boost in quality of predictions. What is the cutting edge error rate accuracy for a computer vision that is achievable in industry? Are we at 2, 3, 4 nines? It's all depends on the problem and on the data set, problem. So for example, there exists a classical computer vision data set called the MNIST. This is the task of digit recognition, handwritten digit recognition. And this data set is solved to 9 nines, yes, probably 1 9, 2 nines, 2 nines. But a lot of data sets are complicated, much complicated than handwritten digit recognition. And in these data sets, we have much lower numbers. So, and this is not we are aiming to do because, for example, data sets can be, they are not perfect because people annotate these data sets, and people make errors, and these data sets also contain errors. And if you have millions examples, of course, now you just, okay, yeah, there are some errors, but not at all. Probably it's okay. I'm going to live with it. I'm not going to look through millions of images and find these errors. It's very, so it's very expensive in terms of time and money. So yeah, it all depends, data set and problem. This is an interesting point about reinforcement learning. All these algorithms, even the first breakthrough in the field, Atari games, were using convolutional layers to process images and theoretically actions and rewards should affect these layers as well. I wonder why nobody tried to understand this relation, or what are the challenges there. Yeah, it's actually a good point. I completely forgot about this paper. Yeah, there was a paper where algorithm played Atari game by looking at the screen, and the results were no, they were great. Yeah, the algorithm sometimes played better than people. And yes, this is an example when we have the complete connection between perception and our actions. Um, and actually, OpenAI algorithm called AlphaZero is also this algorithm plays game of Go, also analyzing the state with the convolutional neural network. That's right. But yes, that's right. There exist some such approaches. But what I wanted to say is that in the difficult environments, where, for example, we are operating in the 3D world, and there were some papers where algorithm tried to learn playing Counter-Strike, for example, and using only the visual information from the eyes of this of the player, and this algorithms performs much worse than algorithms that researchers provide the complete definition of the scene, of the actors, and all the actions that can be done, I think. But yeah, it's very it's very it's not a border, yeah, I mean, between the perception and reinforcement learning. It's just the difficult transition. And it's actually the self-driving cars, another example which demonstrated that this transition is very difficult, that it's much simpler to solve the task and to create algorithms where you decompose the problem of perception and action learning. Can a generative adversarial network replace deep reinforcement? Meaning, can we use a gun to create synthetic data which is real enough to be used to train neural networks where the real data available in scarce? Yes, okay, I understood the question. And yeah, there exists such works actually. For example, I don't know, I didn't remember exactly the concrete example, but there was the work maybe from Google where they generated pedestrians, I think, in very they generated pedestrians in some weird poses, and then they placed this generated pedestrians in the scene, and another algorithm learned to detect such weird pedestrians. So this is one example where GAN was used to create a synthetic data. Uh, Synthetic data. Yeah. Such works exist. What would be some interesting topics in the field of computer vision to pursue a PhD in? I can tell about myself. Yeah, what is interesting for me. Personally, I'm interested in depth estimation that I demonstrated to you. It's very interesting problem, understanding the 3D world only by consecutive photos or video. Yeah, it's very interesting problem, and it can bring us a lot of new applications that we are not thinking even about. For example, having this algorithm, you can, I don't know, maybe apply some new clothes on yourself just with your smartphone and look, do you want to buy this clothes or you don't want to buy these clothes, only using your smartphone. So like generating a look of you in new clothes. And yes, so depth estimation, sensor fusion that I'm working on now is also very interesting task. It's very difficult, like how we can merge 3D data from the LiDAR sensor and the camera sensor. It's really difficult. A lot of, I think, yet to come. So yeah, and I have a specific problem in mind. So I already mentioned it. Having a picture of a person and having a picture of clothes, put these clothes onto this person. So it can it can push the internet commerce to the whole new level. And but this is very difficult problem because it's very difficult to generate realistic view when you have all this I don't know, shadows and textures and so on. So it's very difficult. It's very interesting. Maybe I would do this, and it can be converted into a startup. Okay. I have another question. You mentioned Kaggle and Coursera as the top learning resources. Would a few pet projects using them be enough to get an ML job in Yandex? So I mentioned them because with Kaggle and Coursera, you can gain an experience that you need. And in Yandex, we have you do not required to have a Kaggle in the resume, of course. So all we are looking to is your ability to so actually your theoretical knowledges of deep learning and machine learning in general. So do you understand it well? How would you solve certain tasks? Or how, so we are requiring a very deep intuition about deep learnings. Why, for example, this layer works. What is the intuition behind this layer? Why this and not this? How we can I don't know. So why we are asking this is because we sometimes we need to create new algorithms. We need to come up with new ideas, maybe sometimes we even write papers. So yes, we require a deep understanding and intuition, and we are not requiring Kaggle and Coursera. Kaggle and Coursera are just resources that can help you to gain this knowledge. And yeah, having a good understanding of machine learning and computer vision, and if you have a good programming skills, uh, uh, if you have a good programming skills we are also checking in our application steps, then you will be able to apply even in self-driving cars. Yeah, we are always happy for newcomers. Will this master make me eligible for a PhD? So probably.
And maybe it is the question
Yeah.
for me. So yeah, if you're talking about our Master of Data Science program, after completing our master program, you can apply to the PhD. So there are different requirements in different PhD programs. So you need to check all requirements in advance. But yes, so after our program, you will receive the master's degree, and it is possible to continue your learning in PhD.
Okay, so I answered all the questions. If you have, yes, you
Oh, there
have.
was
Okay.
two questions.
Um, can we get the detailed syllabus of the master? Oh, so I think this is questions for you, Katya.
Yeah. Detailed syllabus of this master's program are what are the topics materials we need to go through for the entrance exam. Also, do you think this program would help someone like me who has some understanding of computer vision with a master's in robotics? And my intention is to pursue a PhD in this field. So I can share the link to our master's program. Let me just one moment. And we also had an admission webinar, and you can visit our webpage and view the recording, watch the recording of our last webinar. But to be eligible to apply to our program, you have to have at least bachelor's degree and pass successfully our entrance exam. So I will copy the link to the chat so you can copy it. And what about detailed syllabus? You can also find that information on our website. And in case of any questions, here is our email address, mds@hsc.ru, and you can send all questions to this email and we will reply very soon. Yes, so I answered to that question. And regarding the detailed syllabus and so on, please email us and we will provide all information. There are no GPA requirements, so there are two requirements. First of all, at least the bachelor's degree, and the second one, you have to complete successfully and pass successfully our entrance exam. It was about the admission, and I think that another question is to you, Artem.
To me, yes. Rather personal question to Artem, if I may ask. Could you kindly tell us how you entered Lambda project? It is a very interesting HSE laboratory for MDC grads. So if, yeah, a few years ago, or 3 or 4, the Lambda project was a shared project with the Yandex. And after the first oh yeah, I remember. I can't remember how I entered this. I applied to the high energy physics machine learning school, which happened in Sweden. The Lambda laboratory was the organizers of this school, and yeah, I just performed well there, and then the head of the laboratory offered me to make some small project. I did it. Then then this project was a shared project with the Yandex a few years ago, and I applied to internship in Yandex, and I after my application process, I went to this Lambda project as my Yandex internship. Um, and then I worked there for like about 8 to 8 months after my internship, and then I um, I went to Yandex Soul Driving Group also for an internship in the beginning, and yeah, and left there. Okay.
Yeah, I think that it was the last question, but if you have any additional questions you would like um, to ask about the program or about the computer vision, you can always email us. And oops, there is another question. How difficult this program might be if a person doesn't have any technical education? I can say briefly that you are more than welcome if you are not with the previous technical education. It is absolutely okay. So we accept people with different backgrounds, but in case of detailed information, email us and we will provide more detailed information. Okay. Thanks everyone for joining us today. And Artyom, thank you so much. So wish you all good luck and have a good day, have a good evening. Thank you once again. Bye.
Thank you.
Stay safe.
Goodbye.